所以我这个去告诉我才是按上面去，所以我在跟老师我想从这个你们这个东西，这样，然后要一些觉得没有在还有就是直接从我知道怎么样。你用这个做你要看哪里没事两次，随便改两次，别人弄你的一次。
Why you use identity? Oh, okay. You are not using it, just want to explain. Okay, for this doing, let me explain the overall flow. There are two ways. One is you use the chain rule, meaning that you put a lot of symbols for different parts of the equation, for the function here. So you start by 3 cos to the power of 4 u. U represent the sign, everything that you change. Okay, but for lazy people like me, we use outer to inner. Just like what maybe he is trying to do. Inward for outward. Inward for outward. Okay, continue do yours. So for outer to inner, meaning that we start to differentiate cosine to the power of 4 first. How do you differentiate cosine to the power of 4? Use the power rule. Take the 4 to the right. Multiply with that, right? Then you get 3 cosine to the power of 3. No, 12 cosine to the power of 3. After you multiply 4 into the 3. Then you need to differentiate the cos to get minus sign. So you will have two very long terms now. 12 cos to the power of 3, the long thing. Whatever is inside that. Multiply with minus sine to the power, minus sine, the very long thing inside that. If you miss the minus sign, which most of you, some of you miss, yeah, that is because you haven't understand. You do not remember the part how to differentiate cos or sine to the higher power. That's trigonometry to a higher power. Okay, we are done with the cosine. Yes. Yeah? Okay. So you have done with the cosine. Let's move one layer inward. So now we want to deal with the sine. So we differentiate the sine, what do we get? We get cosine. So you cosine and the log whatever is inside there, you write it. Then move one layer in. Now deal with the log. How to differentiate log? Like log 2x. You put the 2x in the denominator, and you put in the numerator you put what is the derivative of 2x. So same case here, you put the cos of 2x squared plus the exponential in the denominator, and then you the cos of r. Then you differentiate the cos, you get minus sine of whatever is inside there. Then finally, you need to differentiate the 2x squared plus exponential x squared, which come to the innermost layer. You are done differentiating that. Done. So it's still like it. That's about it. That's the process. So remember when you have a very long chain like this, a long formula or function like this with a lot of brackets, move from the outward slowly inwards. That's one technique. If you have your own technique to get the same answer, by all means go ahead and do that. Yes. Oh, I got color some more. Good. Very good. Okay. Separate. Okay. So on average, if you see this kind of question, on average, I think you will spend around, it's long about 20 minutes. Because you just want to see it. If fast, then about 5 to 10 minutes. Of course, what I can tell you is you don't see this kind of question in the exam. Just to test your skill in chain rule. If you can do this kind of thing, then of course you can do different kind of questions that are related to chain rule. Okay? So congratulations for those who can get the answer that I hope one now I didn't cover everyone. But if you get the answer and if you want to verify later, come to see me. It's still writing, so I do mine. I write mine. Ayo, so complicated.
Not like this, man.
Huh?
Not like this, man.
Huh? Later, ayo. Right. So let's do the outer to innermost. 3 multiply with 4 cosine of 3. Whatever is inside, you just copy. And then multiply 1 square bracket. Multiply with the minus sign. I put 1 star here. Okay. Because I'm lazy to copy everything. Minus sign, 1 star. Got it? That is the outermost layer. Then we move 1 layer in, meaning that this is layer 1, 1 star. Now layer 2, 2 stars. So we are going to do that layer 2. Layer 2, if we differentiate cosine, what do we get? Just sine, we get cosine. Yes, we get cosine. And then 2 star. Meaning that whatever the ln there. Okay? Now 3 star. Moving in 1 more layer, ln. So, if you want to differentiate ln, usually ln, say, x squared. What do we get? X squared in the bottom, and at the top we differentiate the x squared, we get 2x, right? That much is clear. So, we are going to write cosine 3 star. 3 star means that whatever is inside the this here. And in the denominator, in the numerator, it should be minus sign, right? Have a 3 star there. Then we have actually done with the ln and the cosine. Okay. So after that, what should we do? 3 star. Become 4 star. So what is any last bracket here? What do you think is the next bracket? Huh? Which one? The 2x, right? So you need to differentiate the 2x. So you get 4x plus differentiate the exponential, you get 2x ex squared. Am I missing anything? I hope not. Done. Okay, that's about it.
That's about it. I still haven't finished.
Ayo. Okay, so to avoid taking so long, right? You can actually say this t or u term equals to whatever things that. Let's say you define that sine, ln, cos 2x squared plus ex squared. This how many bracket? 1, 2, 3 brackets. Maybe you put it as p lah, whatever is that. You just put in there, so that your answer is shorter. Then I can refer to the specific letters to know that what are the expressions inside there. Also make you less confused. You don't have to write the whole expression to be super long. Just make use of letters. My God. Okay, that's about it. Why your one is so complicated? Look at my answer. Huh? It's supposed to be. You're trying to simplify it, is it? Okay. Now, okay, I stop you. And return the pen is not mine. Okay. Alright, one thing that you need to remember, if the question is like long chain rule like this, I'm not expecting you to simplify it. I'm not expecting you to factorize or simplify it. Okay? So you can just use the bracket, square bracket, to categorize your answer nicely. Okay? Right. That's it for the chain rule. Now, are you familiar with chain rule? Hopefully yes. Hopefully yes. Will you expect to see this kind of question in the exam? Yes, but not to this extent. That's the thing I can tell you about test 2.
Just want to best class.
Huh?
Just want to best class.
Pardon?
Just want to best class.
Oh, yes. See, I have successfully wasted 45 minutes. Something. That is important. That is important, alright? So, let's get back to what we're supposed to learn today. Actually is ODE tutorial. I want to finish the tutorial today. I will discuss question 1, 3, 4, 5, 6, and 7. Not all the questions, but some.
So the tutorial class later.
No, the tutorial class for this week is still on. Just that during the tutorial class, you will see the question number 2. I will cover the rest of the question in today's class. So that we don't have class on Thursday, and we can have a class on next Tuesday just to discuss the test. Okay, right. Let's get to the next part. Here, question number 1. I will go through it real fast because it's not tested, but it's good to know. Question number 1. For each of the ODE, find the order at the degree. So the part 1, we have y triple prime plus xy double prime plus 2y prime square plus xy equals to 0. So when it comes to order, it should be the highest derivative. We can notice that the highest derivative is this. So order equals to 3. And then, when it comes to the degree, you look for the power of the highest order, which is 1. In this case, you can see the power is 1. Done. Now, part 2. Part 2, sometimes you see that the expression, maybe I write part 3. Part 2 is easy. Part 3, you see that it is written in terms of d something over d something. It's okay if you're comfortable looking at the derivatives in such form. If not, then I recommend you to write it as prime. So d3 prime meaning that d3w meaning that we have order of 3 square. It's not equal sign. Typo is minus w square to the power of 4 plus vw equals to 0. So what is the order? The order here is again 3. And the degree, what is the order? The so-called the power of the highest order. In here it is 2. So just 2. The last one. We have a square root, meaning that the power of 1 over 2 equals to sine x. Now, when the power in the ODE is not an integer, make sure you change it into integer. Now it is fractional, 1 over 2, so not legit. So we need to square the both sides of the equation. If we square it, we get y prime plus y on the left hand side. And on the right hand side, we have sine square. Then only after that, you can decide which one, what is the order, which is clearly 1, and what is the power of the order, which is degree equals to 1 as well. Take note that this is just for your knowledge so that you don't get confused in the future. Another tip for you, it won't be tested because this one is too basics. Now, moving on to the third question. The third question here, we have to solve second order ODE. But if you look at the equation, you notice that we have y double prime here minus y equals to 0. Now, when you have second order, due to the limited syllabus that we have in this case, you just need to make sure that your one of the side consists of all the y terms. That makes it linear. So, in this equation, you try to verify is it linear or not on the left hand side. It seems to be linear. Linear meaning that it has a specific form. Refer to the lecture notes for that linearity. So in this case, on the right hand side, we have 0. So it is homogeneous type of second order ODE. And in this case, we just have one general solution. We don't have trial functions. Trial functions only for the non-homogeneous case. So in this case, remember the part where we have m squared correspond to the y double prime. M correspond to the y prime, and then constant correspond to the coefficient of y. So meaning that in this case, we have m squared minus 1 equals to 0 as our characteristic equation. Then we take m minus the 1, m plus the 1, then we have two distinct real roots. When we have two distinct real roots, we can say distinct real. And we can write it as, where is it? Y equals to AEX plus BE minus X. Right, that's it. We don't have any initial values. We don't have a values for X and Y, so stop it. That's a final solution. Now on to the second part. For second part, we just change the sign between the y double prime and y prime, and everything change. We have m squared plus 1 equals to 0. If you have some basics in complex number before, then you know that your answer here, the m is equal to 0 plus minus I. If not, you use your calculator and you get the 0 plus minus I. Now, in this case, since we have complex root, then our general solution is y equals to, following the formula, is a cos x plus b sine x. Refer to the lecture notes on what is the general form for this kind of condition where we have complex root for the m. You need to memorize that. Put a note there and memorize it because it's not given. It's not given. And I believe that this, for the ODE, this part of finding the m from the characteristic equation and form the general equation is one of the easiest things in the ODE chapter. And you somehow, for second ODE, you must do this. So make sure that at least you memorize it and you get something out of that. Now, third part. We have, again, I don't like to see d over d something, so I change it into y double prime minus 4y prime plus 4y equals to 0. So following the rule of thumb, we try to construct the characteristic equation, which is m squared minus 4m plus 4. Now, do you need to show off your factorization from here? Well, the answer is no. If you want, if you're more comfortable with doing the factorization and get the values of m from there, then you can do that. If not, use a calculator. Yes. You mean A and B, or C or D? It's up to you. It's just letters. Yeah. Just make sure that if it refers to different constants. If let's say in the trial function later on, you also have some constant there, you use different letters. Don't use the same letters. So with this one, if you use your calculator, what do you get? M equals to 2. You notice that you only have one number. So it means that it is repeating roots. When your m has only one value, then it's repeating, then we know that by formula we can write the general solution as y ax plus b e2x. Remember that yesterday someone asked, why this? Why not that? Okay, so if you are wondering why this or not that, there is one way to derive it. So if you are interested, you can actually refer to the, not my lecture notes. My lecture notes is like compressed version. Interested, you can refer to the proper reference book, which is, you can find it in my syllabus. The Is it teaching plan? Yeah, reference section there. Okay, question number 4, I think I leave it for you. The M is, for part 4, the M you get should be 0 plus minus square root of 7i. Okay, that's the homogeneous second order ODE. Now, same thing, but what if we have initial values for part 1? I'll discuss for part 1 only. Y double prime minus 4y prime plus 3y equals to 0. Characteristic equation, m squared minus 4m plus 3 equals to 0. Solving this, we get m equals to, I always not confident one, m equals to 3 and 1. So the y is a, e, for this time I use the m equals to 1 first, then followed by e3x. Again, you don't necessarily need to follow me having the a for the ex. You can put b for the ex, up to you, doesn't matter. Right, next. You are given x equals to 0, y equals to 3, y prime equals to 11. What you need to do now is, you need to form two equations. Why? Because here, you notice that you have two unknowns. Two unknowns, you need to have two equations. Where do we get those equations? You simply substitute this value, these two values, into here first, and then you differentiate the y, you get aex plus 3b3x. Then you take this x and the y prime, substitute them into the y prime. Then you have two equations. So what are the equations that you get in, eventually? You get from this, let's say I say this is the first equation, second equation, right? You substitute the first one, you get 3 equals to a plus b. Second one, you get 11 equals to a plus 3b. Then you solve simultaneous equation, which this one is super easy. And if you solve it, you get a equals to minus 1 and b equals to 4. So you have the values of a and b, put it into the first equation, so that you get minus ex plus 4e3x. Done. This is your specific or particular solution. Right. Easy, huh? So part 2, same old thing. Characteristic equation, solve for the m, build your general solution. And finally, find the a and b. Yes.
For the y prime initial condition, we always assume that x equals 0 also comes with our y prime.
Yes. It depends on how the question put it. Let's say in here we say x equals to 0, y equals to 3, y prime equals to 11. You can assume that this y prime is when x equals to 0. The more correct way actually to write this statement is usually when you see in engineering questions, say when x equals to 0, then your y equals to 3, y prime equals to 11. Or another way they like to write is y 0, 3, y prime 0, 11. Essentially, they are the same thing. So you need to learn how to recognize where is the x, where is the y and y prime. Okay. Next. Second order, non-homogeneous. For second order non-homogeneous, you have one more thing to do, and that one more thing is annoying. That's called the trial function. Question number 5 here. Let me see. Maybe all of them I try to discuss. Y double prime minus 4y prime plus 4y equals to 8x plus 4. Okay. So in this case, we have the characteristic equation and the trial function. So in here, we begin by writing the m squared minus 4m plus 4 equals to 0. But before that, make sure that the side of equation that consists of the y terms it is in the linear order, linear second order, linear format. Okay, if it is not linear format, for example, I plug in plus 2 here, and please move this plus 2 to this side before you do anything. Yeah, right. Now, m squared minus 4m plus 4, answer. We get m equals to 2, repeating. Again, you don't have to write the repeating, just make sure you write the correct so-called solution. So yc, just to differentiate a little bit from the trial function that you want to get later on. So yc is equal to ax plus b e 2x. Now we have our yc. Next is the trial function. The trial function is the part that is challenging. For this case, we have 8x plus 4, obviously some polynomials. So what we need to do is our trial function, maybe we put it as y. Y equals to cx plus d. Because as you can see here, the power of the x on the right hand side is 1. So cx plus d. If it's 2, power of 2, then we have cx squared plus dx plus e, so on and so forth. So for the y here, if we differentiate it once, we get c. Differentiate it twice, we get 0. What are we going to do with the derivatives? We take all this expression, all this, plug it on into the left-hand side here. So what do we get if we plug in? We have 0 minus 4 y prime is c plus 4 cx plus d equals to 8x plus 4. Then you need to compare left and right. At this stage, please do not move any terms from the left to the right. Too late to do so. Okay? So minus 4c plus 4cx plus 4d. So we have 4cx I put a bracket for easy reading. 4cx plus 4d minus 4c. Then when doing the comparison, you compare the corresponding terms. X with x, x squared with x squared, constant with constant. So in this case, 4c equals to 8, c equals to 2. 4d minus 4c equals to 4. Since c is equal to 2, we have 4d minus 8 equals to 4. So eventually our d is 3. So eventually our y here, y here is now y 2x plus 3. but that is the trial function, not the complete general solution. The complete general solution is supposed to be y, yc plus the, if I put yp for this, yp. So we have ax plus b e2x plus the 2x plus 3. That is the general solution. So you can see the part is more tedious when you have the trial function. Now for the second and the third part, don't want to spend too much time trying to explain the same thing to you again. So I will focus on the right hand side. Second, am I going too fast on this? Anyone want to take down? No? Okay. Oh, you want? Please take. Anyone else? No? Okay. Oh, relax. Good. This one is not supposed to be hard. It's just tedious. I tell you, ODE is tedious. Second order one is tedious. First order, quite challenging. Part 2. On the part 2, on the right hand side, I just focus on the right hand side now. 20e minus 2x. This is the terms. So if we have this exponential term, what are we going to? Our trial function is c what? ce minus 2x. So we just disregard the 20, whatever number is in front of the e doesn't matter. Whatever number in front of the e doesn't matter. The power of that exponential must be the same. So if you differentiate the trial function, what do you get? Y e prime equals to minus 2ce minus 2x. Then I think you can do the rest. Substitute, compare. Third one. Right hand side. Cosine 2x. When you have trigo, just for sine and cosine, I'm not talking about tangent, secant, whatever other trigos. At your level here, cosine and sine is good enough. Okay. If you ask me tangent or secant one, that one I need to prepare as well. So cosine and sine only, don't worry. When it's just cosine itself, cos like this or sine like this itself, as long as you have sine and cosine on the right hand side, your trial function, the safe one, is always the c cos 2x in this case plus b sine 2x. Although we don't have sine, you also put in the sine. Why? Because if we differentiate this, we get something like, say, minus 2c sine 2x plus 2d cos 2x. It is comprehensive, cover everything. Right, then when doing comparison, I know after you substitute these expressions into your second order ODE on the left hand side with the y terms there, you get a long one. So you need to gather the terms so that it is something cos 2x plus some other things sine 2x. You must be able to gather the terms and group them in such way. Then only after that, on the right hand side here, you have cos of 2x, right? This is 1. So when you want to make use of the star, you make it equal to 1. Because on the right hand side, we have 1 cos 2x. But on the right hand side, we don't have any sign terms. So your triangle here, when you do the comparison, equals to 0. Why do we need to have these two stars and triangle? Because we have two unknowns, the C and the D. You must get it. That's why I need two equations. Clear? The next question is about initial value for this non-homogeneous second order ODE. I just want to discuss question number part 1. Again, anyone need to take anything from here? Right, next one. Only part 1 is need to be discussed. Y double prime minus y equals to e minus 2x. Okay. We have m squared minus 1 equals to 0, so m equals to plus minus 1. Then we have y equals to ae minus x plus be x. As you can see, if you do it frequently enough, it is super fast. If you are not doing it enough practice, you do like slow like that. Now for the particular solution trial function, our trial function is like yp, yc here, equals to ce minus 2x. So yp prime equals to minus 2ce minus 2x. 4ce minus 2x. So you plug it into here. 4ce minus 2x minus the ce minus 2x. Okay, I a bit lazy, but don't do like this. Don't. It's dangerous to do so. Okay, maybe I should put 4c minus c, and then e minus 2x like this. I factor out equals to 1 e minus 2x. Then I know that 3c equals to 1, c equals to 1 over 3. Then this will be yp equals to 1 over 3 e minus 2x. Going very fast with the trial and the yc and the yp because that's not the main point of this question. Here is the main. We have our general solution, then we have the initial conditions, right? You notice that your initial condition is a bit weird. You see that your y is equal to 0. Say, okay, good. Your y, when your y is equal to 0, your x is equal to 0. This is one set 1, okay. Set 1. Set 2, not okay. Your y is going to 0 when your x is going to infinity. That is the part where you are not okay. Some of you not okay. So how to deal with that? We have a and b, two unknowns. We definitely need two equations. So one of the equation we get it from set 1, another we get it from set 2 naturally, right? So let's do the set 1. Since that the set 1 is easy, if you plug in set 1 into the y here, you get 0 equals to e to the power of 0, we get 1. As you can see, right? So a plus b plus 1 over 3. This is coming from set 1. Set 1. Set 2. When we see approaching, we can just plug in the values. I mean, so I use the word illegally plug in. It's 0. Okay. A, e of negative infinity plus b e infinity plus 1 over 3 e minus infinity. Where goes the 2?
multiply into the infinity, become infinity, part of infinity. We don't care about the 2, it's too small already. Small potato. Not important, so gone. So now we have the minus infinity and positive infinity. Then you take your calculator. You should get this equal to 0. How do you know that it's equal to 0? You try lah. E minus 1 million and see. What do you get? Is it a very, very, very small number? A very, very small number, close to 0. That's why I say illegally we say claim it to be 0, but rightfully it is 0. It's not exactly 0, but very close to 0. So this one 0, this one 0, happy. Then comes to the part that need a little bit of logical thinking. We get rid of the A, we get rid of the last term, we still have the B terms here. What are we going to do about that? Then you say, I can do this, I can also do this. E infinity equals to what? You take your calculator, calculate E infinity. Maybe E to a very large number. A very large number. If you remember the exponential graph, how does it look like? Like, whoa, like that lah, like that. Curve a bit but going out. Will it ever be negative? Will it ever touch 0? No. No. So, E infinity not 0. If this is not 0, how to make this 0? The B must be 0. Yeah. Deduction. We call it deduction. I don't know whether I'm using the correct word or not. It's logical thinking. This whole equation here, this whole thing, legit. Legit meaning that B multiplied with E to the power of infinity is 0. And then we know that the E infinity is not gonna be 0 in whatever way. In that case, in order to make this equation legit, the B must be 0. Like that. You can just say from deduction, or I think this is a correct word. Long time never do a proper pure maths already. Indicates that 0 because you say that E infinity is not 0. So in order to say this, you say E infinity is not equal to 0, so B equals to 0. Like that. Now you have B equals to 0, you know your A from the set 1. Then you'll get your answer. Good. How many of you don't get it? Anybody don't get the concept of idea of this? Just honest, raise your hand, it's fine. I will try to explain it in another way. Anyone don't get the idea? Very good. So that's it for this infinity case. Last question. Using the substitution u equals to dy dx, solve the differential equation and with the initial conditions given as below, right? This one, by its own ODE there, when the question say use something to solve something, you use that, whether you like it or not, use that. So it says u equals to dy dx, you have to use that. We are given this 1 plus dy dx squared equals to 2x dy dx and then d2y dx squared, like this. So how do we find this? If we do the substitution, we just do it. 1 plus, when you see dy dx, we put u squared equals to 2x u. But how to get the 2y dx? Second order. Well, you just need to write, say, differentiate the, you see, differentiate the u is essentially taking the dy dx and differentiate, right? So you have second order lah. So we have du dx. So we can write here u prime if you want, or du dx lah. Then you have simplified it into another ODE, still ODE lah, but first order lah. So what is the impressive things here is from second order is reduced into first order. And instead of using second order to solve it, now you can use first order technique to solve it. So what is the first order technique you can use to solve it? Well, depends on your observation or luck sometimes. So in here, it seems like we can separate the terms completely in terms of just u and x. So in this case, put it here on the left hand side. Maybe we just put all the u on the left hand side. So we have 1 plus u over 1 plus u squared du. So this over here, du remain. And this 2x and dx, we put it over here. We have 1 over 2x dx. Separable method. So we have ln of eventually you get 1 plus u squared after some simplifications. Take note that after some simplification, that's why some constants are missing from here. That is the answer that you get after you try to disintegrate both sides and simplify. So here so far, can you follow? Okay, okay. Cannot follow, also need to follow already. Now you have initial conditions, right? You have the plus c. You want to get the c first. Of course, you can substitute the u equal to dy dx right back into the things, but that doesn't actually help you much with the. It may help you, but not very much. So for here, when we are given that when x is equals to 1, our u, which is the dy dx, is given as 0. Read the question, you notice that dy dx is equal to 0. What is dy dx in this case? We are asked to substitute it using the u. So whenever you see u, it is dy dx, so it is 0. So you plug in 0 into here and 1 into here, you get ln 1 plus y equals to dy dx equals to 0. Read again. Both of them equals to 0. The y equals to 0. Your dy dx equals to 0, but u is equals to dy dx. So by logic, u is equals to 0. No. U equals to dy dx is u equals to dy dx. The other statement here say, just so happen that in that initial condition, y and dy dx, they are the same value. U and y, no relationship. U and y, no relationship. U and dy dx, they are the same. Okay, u is the derivative of y. In that case, do not confuse yourself with the y equals to dy dx equals to 0. That is only when x is equals to 0. Like that, understand? Okay, good. You confused me a little bit. 1 plus 0. Good attempt. 1 plus c. So you get ln 1 and ln 1 on equals to 0 lah. So 0 equals to 0 plus c, so c equals to 0. Okay, so ultimately we have this. this is not the final answer. Our ODE is in y, in terms of y and x. So our final answer should be in terms of x and y as well, not in terms of u. So let's plug it back. But before that, we can get rid of the ln. This one, law of logs. Okay. Then 1 plus dy dx square equals to x. Then dy dx square equals to x minus 1. Then taking the square root of both sides, we have this. Now let me stop a while. Let you take a photo or write it down. By the way, not done yet. Not done yet. Let you digest a little bit. Because halfway through, I already lost my direction. Now, the last step is I integrate the dy dx here. I integrate it and I get y equals to plus minus 2 over 3, x minus 1, 3 over 2 plus c. Then suddenly my initial condition comes back again. Y equals to 0, x equals to 0 in order to find that c. Substitute in, you get c equals to 0 again. So ultimately, the answer for this whole thing is this. Okay, instead of me explaining the whole thing, you take down the answer, think about it, ask me if you don't understand. Right from the beginning, now think about the purpose of why we do all this, what is the ultimate purpose of solving the ODE, what should you expect, and think about it. Don't understand, ask me. Right, 2 plus the x equals to 1 at the end. One. At the beginning of the ODE, this chapter, when we talk about what is the definition of ODE, of course it has a certain form, but solving an ODE should give us a function, say y equals to something, right? So halfway through, when we get to the point where we have the ln of 1 plus u squared equals to ln x, that one is not the final answer, because we haven't get y equals to something. By solving the second order ODE or first order ODE, we should get y equals to something. That's why we continue to put it into the, to continue to solve it by substituting the u equals to dy dx into the equation and write it as dy dx and integrate it so that we get the ultimate solution of y equals to something. That's the whole purpose. Yes, that's it. Nothing else that I can teach you anymore. Okay, that's it for today's class. Next week, next Tuesday, still have got class. If you are interested about your test result. Okay? And attendance, let me give a 5, 3. Me is like getting really not over but taking my gathering energy and few powers. Oh, okay, because Wednesday. Oh, yes. And x equals to 0. Oh, this is from the below. Why we need the below one is because in order for this function, when we have fractional function like this, how to get critical point? One is when it is equal to 0, another is when it is undefined. So when it is equal to 0, we just take the numerator from minus x equal to 0, we get this. And for this function to be undefined, we need the 0 in the denominator. So 5x to the power of 2 over 5 is equal to 0, we get x equal to 0. Oh, okay. First, you need to know what thing you want to optimize. Okay, the thing that you want to optimize is find the size of the square to be obtain the largest volume, hence find the largest volume. Meaning that you want to construct the volume first. So the function that you want to optimize is the volume. So you define the volume first. Volume is base, the length, and the width, and the height. Okay. So the length and the width, because we cut out x from the length, cut out x from the width. So we have xx. So at least for this 61, we minus 2x. Let's say this length. 30 we minus 2x. There's the width. And then multiply with x, and we get the volume. This is the function that we want to optimize. Then you carry on with the critical point.
The volume will become like this.
Yeah. You take the paper, you cut out 4 corners, exactly the square one. Take them up. That is your box, right? What is the volume of the box? The length multiply with this one and multiply with the height. This is the volume formula that you get. So you're going to take v over dx and then critical point. after the critical point, you will see which critical point will give you Dr. max or Dr. min by doing the second derivative.
There's a formula, but actually you use the normal so cannot be use the formula faster.
Well, if you find that you can solve it without using the formula, by all
The answer is different.
So you get this one is minus 1. Minus 1 for Z. Z is usually we go into 1. So when it's minus 1, it means that's pointing down. So if you want to flip in positive 1, flip the sign of it.
So it depends on the sign.
It depends on the Z sign to define outward.
For this question, how the vector point in the direction of the place depends on the picture. Actually, it's telling us to find the vector.
Yes.
Remember.
Okay. Yes, continue.
For this question, I found out that
Yeah, you get 1 over 0.
Yeah. So the answer is undefined. Then for this question, I found out that no need to sub the value.
No need to sub. If the question asks for sub value, no need.
Then how to know no need sub the value?
Because this one supposed to have no need. I accidentally put in the pi.
Then for this kind of question, the pi also in radian form.
The pi also in calculus everything in radian. For the
So normally you need to sub inside.
Normally, depends. If you have the upper bound, lower bound, upper limit, or lower limit like that, then you need to sub. You know how to sub for substitution, sub value.
Then you change the
Correct. Then how about the by parts? The UV one you need to sub first, then only you can write the formula. And then the integration later also using the same limit of integration.
no need change like this.
No need change. Then you are good to go. This one see better.
Not because for the previous question, x is square, and for this one, x is not square, but then suppose it should be like this. Then why the square root the 8?
Must be hyper. Yeah, it should be that. Yeah, it's Top by 4 minus C whole
This one how to see the answer? I can't.
Okay. What do you mean?
This
This here you have expanded.
yeah.
Then you have done this 9 plus.
I done until here. Then I don't know how to solve this
Now t to the power of 4. You try to factorize t to the power of 4 to t square and 1 to the t square plus 1 square. Yes. So when you have t square plus 1 square and then you square root it from the same t square root then gone. Change gender already. Have you tried the tutorial?
If tutorial okay, then that's okay.
There are some integrations which I cannot disclose what type. But just now, differentiation I can tell you. That will save you a bit like chain rule. Can you do that? How to chain rule one. You can do it, and the rest is see your integration skills. The rest, the questions are very direct. Very direct.
No, this.
No, very direct one.
So
Integration not telling you to skip. Integration means that I purposely put it as a last section. So if for the time, you make sure your other okay first, then only you go play with the integration. I purposely put it as the last question in it because I scared students I stuck there centuries like that. Okay.
what is the purpose for separate the minus?
Oh, just so that it is in a form that is quite similar to this.
If the one cannot,
If the one
separate.
the one separate it,
Yeah.
if you can recognize it by your eye, then you know that it is minus x over the 14. If no, then better separate it so that it's clear that it is quite similar to this one.
So can you teach me how to do this?
This one is a more advanced one. You only need to know the Magnolia and the Taylor series.
So
Our series no need. Our series no need. But Taylor and that one and how to use the Taylor and Magnolia, approximate that one you must know. The trigger sum, trigger sum that one also include also need to learn.
Because tutorial don't have.
But lecture got. Everything included in the lecture. If you ask me, I will say included. If you ask me specifically, I say don't have, then memang don't have. Yes. Yeah. This one. Right, the question I asked you by the Magnolia series, so you use the Magnolia series formula for sine and cos.
then this one I write wrong.
Oh, your cos and then the sine should be correct.
I know
Oh,
this
my
correct.
answer is incorrect. My answer is incorrect.
Okay.
Your is correct one. Okay. It's supposed to be x, there is no cos or sine.
So the answer for here is correct.
My answer is not
Yeah,
yes.
okay.
So just x and no x.
Do we need to expand this factorial out? Or just leave it like that?
You mean your answer? Don't leave your factorial for me to calculate for you lah.
Like this one, I try this.
Like this okay. Like this cannot.
No need to factorize this.
No need.
No need expand.
No need. What?
Thank you so.
Okay. You want to tell already? Bye bye.
Then for this question got minus.
Yeah. Got minus
Got
Yes, is that? Which one is this? Why you highlight minus?
I want to ask got minus 7 because I calculate it's got negative.
This one is implicit, right? Partial derivative. Supposingly, that is the minus sign.
Oh yeah. Here got the
I don't know the sign and things like that. Okay.